Hello everyone, this is a video lecture for Calculus 2, section 11.6, ratio and root tests. So the ratio test looks something kind of like this. We got the limit as n approaches infinity of a sub n plus 1 divided by a sub n. If it's less than 1, then it converges. If it's 1 or more, then it would diverge. So this n plus 1 subscript is actually the next term. So this is the next term, while you can basically call this the current term. So what we're going to do is plug in an n, and then on the top we're going to plug in an n plus 1 and just kind of figure it all out. A lot of stuff is going to cancel, etc. So the root test is a little bit more simplistic. It's the nth root of a sub n, but this is a very special purpose one. If you have like an n power, then you could do the nth root. Again, they cancel, and you can just do the same thing. So don't use root test every single time. Ratio test, I've used it a whole lot over the past. It's a great one. You could pretty much just use ratio test all the time, but I'm going to show you again that you don't have to use it all the time because there's other approaches. So let's do some problems here. We got 11,6,003. And so the summation of n equals 1 to infinity of n over 7 to the n. And they say, hey, does this converge or does this diverge? And there's one other thing that WebAssign wants actually in particular here. They actually, like part A, this is a part B thing. Part A, they say, well, find a sub n. And this is really silly because it's right there. It's just whatever you had on the inside. I don't know. I put duh WebAssign because I don't know what else to say. That was it. We still need to figure out if it converges or diverges. If you're looking at this, what you actually have right here is the linear term, which is kind of related to polynomials. And then what we have here is the exponentials. The exponentials get far bigger in the end. So what we got, if you just kind of imagine, we got some kind of number, and then we got a really big number in the bottom, and so eventually that'll go to 0. Thus, it's going to converge. Converge, and that's my answer. Wow, that was so easy. We did not use ratio test. We didn't use root test. We don't need to do any of those tests. You could just look at it, and I'm telling you, most of these problems, you could probably just do that. But this is an easier problem, and it's a good introduction to ratio test. And I'm gonna show it to you so that you know what to do on the harder ones where you do have to use it. So we're gonna do the ratio test. Limit n goes to infinity, whatever. And so we have the next term in the top. So wherever you had an n, you put an n plus 1. And then in the bottom, you have the current term, which is just a copy paste of what you already have. And we need to simplify this down a lot. So what I start doing is we got n plus 1. Here we got 7 to the n times a 7. I got an n, and I got a 7n. Some of the stuff cancels out pretty quickly, like these two guys right here. That 7 is actually left out. You can't cancel him. But you can bring it to the front as a 1/7. I don't think that's going to matter here. And so what we end up with is n plus 1 over n, something kind of like that. What's kind of interesting is that if you're looking at this limit here, this basically just goes to 1. Now, I don't want to do this. This is bad math. But basically, you're saying infinity over infinity, and they cancel. This is so bad. Don't think like this. What you should be thinking is L'Hopital's. So what's the derivative of the top and the bottom? Or you could do, these are the same power in the top and bottom, so what's the front fraction for the horizontal asymptote? Blah, blah, blah. Ultimately, you should just say it's that 1/7 times 1, which is 1/7, of course. And that is less than 1, which was our condition for converging. So, and I had said that way long ago that we converge. So see again, if your ratio is less than 1, it converges. And that's it. Okay, so I showed it a long time ago. You didn't have to do this, but I did it anyways because I wanted to show you. 11,6,010. So I've got summation into an infinity. I'm sorry. N goes to infinity, of course, but of n factorial divided by 108 to the n power. That's kind of weird. So, converge or diverge? I'll wait. No, I'm just playing. So, notice the top here is a factorial. I know that the bottom is a pretty big exponential, but factorial is definitely bigger. This is much, much bigger than the bottom. And so the top is bigger than the bottom. What would that look like? You got a whole big old number divided by something kind of tiny. Yeah, that's approaching infinity, diverges. Okay, so you didn't have to do the ratio test. I'm going to do it anyways. And so here we go, the limit n infinity, whatever. So n plus 1 factorial, 108 n plus 1, all divided by n factorial, and 108 n. Notice that I keep doing this like really, really big long division thing. It's so I'm separating them and I don't confuse them. If you just had, you know, divide, 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 it just all kind of muddies together and which one is going where. So I make this one extra long just to say, hey, that's big division. So when I'm doing this, I have the factorials actually, you can expand a tiny bit by doing that. Oh, zoomed in. Zooming in. So yeah, we have the n plus 1, and then the next term would have been an n, so that's good. And I'm going to stop there because that's going to cancel in the bottom. Same thing with here. I'm just going to multiply it by 108 down here, just like in the last problem. That's a 1 power, multiplying their bases, add the powers, that kind of stuff. Just basic algebra stuff. So these guys cancel, those guys cancel. I mean, that's the idea with ratio tests, is a lot of stuff cancels. I got the limit of n plus 1 divided by 108. And what's that going to be? You know, n goes to infinity. So basically, yeah, you get infinity, diverges, which we already had said a little bit ago. Cool. I hope that you're understanding, not that I'm trying to like lack patience or something like that, but it honestly is much easier than what they make it out to be. And you do not always have to do the long route. If you know what's going on, that's great. Of course, if it's really weird, then you should probably do the long way. And I'll show you that in a second. But this guy here, summation, I got -1 to the n. I got a 1.7 to the n. I got n cubed. And this one's actually interesting. Because it's an alternating, we have to do a separate little, I don't know, something or other. And so what we would do is find the limit here, and if it goes to 0, then converges or diverges. This is going back a couple sections. And so find the limit of this specifically. Sorry, my ends are just not that great today. And if you're noticing, we got an exponential here and a polynomial there, and my exponentials are, I mean, you're getting huge. So, yeah, this is going to infinity, which is not equal to 0, so this is going to diverge for sure. Even with the alternating, it's still going to diverge, basically. So, okay, cool, I guess. Yeah, I didn't do any ratio tests or nothing, so whatever. 11, 6, 0, 1, 9. I have summation n equals 1 to infinity, just as usual. 7 times 14 times 21 times 7n, all divided by n factorial. They say, go ahead and find out, well, just converge, diverge, honestly. This one here is a little different. Now, could I look at this and eventually kind of figure it out? Maybe, probably, but I want to do the ratio test to make sure, and this is one of those moments where we should use ratio tests, so that's a good thing. So the top and the bottom here, I'm going to now do the next term. So wherever there was an n, I need to put in n plus 1. Okay, now it's going to look weird, okay? So just hang on tight for a second. Like that. Now, I know that we got the n, and then we got the n plus 1 and all that stuff. In fact, I'm going to do that. I'm going to leave the current term and then the next term. And what I'm going to do is I'm going to distribute that 7 automatically. So again, I had this, and I just said, oh, let's distribute. So it's a little bit faster. And the same in the bottom, I'm just going to go ahead and, I know that's n plus 1 factorial, so it's an n plus 1 and then an n factorial, just like the previous problems we've done before. And then we have all of this stuff here, and then divided by the n factorial. So, n factorials cancel, yes. This guy cancels, this guy cancels, this guy cancels, this guy cancels. Cancel, 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 cancel. And so what we have left over is the limit of 7n plus 7 all over n plus 1. Now, if you notice here, we got the same degree in the top and the bottom, so I'm looking for my horizontal asymptote, which is going to be the front fraction, or you can use L'Hopital's, all these different ways. But eventually, the answer is 7. 7 over 1 is 7. But that is more than 1, and so this is actually going to diverge. Okay? It's going to diverge. Remember that the that's a 7, that's a alligator symbol. And so, again, the condition was 1, less than 1. So this is actually, you could say greater than or equal to 1, it diverges. So, yeah. Cool. So there, ratio test actually is good sometimes. So here's another one. 11, 6, 0, 2, 1. I've got summation of n squared plus 3 all divided by 2n squared plus 5, and all that to the n power. This is a classic root test problem. Because you got that n power right there, if I do the nth root, it'll cancel immediately and everything is really super easy. So there is a purpose for this root test. It's just kind of rare, I guess you can say. But in this particular case, it's perfect. See what happens, they cancel. And so I'm left with the limit n squared plus 3 all over 2n squared plus 5. And again, hey, what's the limit? Well, this is a 1, that's a 2, and notice they got the same power, so the front fraction, again, so it's going to be the half, which is less than 1, thus that would converge. All right, another one. 11, 6, 0, 2, 5. Ooh, that 5 is nasty. This one here actually starts at n equals 5. I don't think that actually matters for what we're doing, but I just wanted to write that down anyways. So 6 times 1 plus 1 over n, all to the n squared, and again converge, or diverge. So again, this is going to be a root test, and the reason why is because we got this n power thing. But what happens, you'll see here, it's like not enough, kinda. And so this is n times n, or powers of powers multiply kind of thing. So it's n to the n power, and so you got an n and another n, and you can cancel one of those with this guy. But what happens is that you don't cancel at all. Actually, sorry, hold on. Pause for a second. Yes, these cancel. But what about that 6? Notice that I was already writing it because, well, I looked at my notes before I did this, of course. You have to distribute this to both terms first. So then this guy has the n, and then this guy's over here, and that's when they cancel. So you watch out for that little stuff like that, because if you had a 6 in the front here, it won't change this problem per se, but you might have actually gone over, like if your answer was like, I don't know, just like a half, but then you said, oh, well, times 6. Well, then it's way more than 1 and it diverges, but really it probably just converged the entire time. So watch out those simple little algebra things. I almost made a mistake myself. So it cancels with one of the ends here, leaving one of them behind. Okay, so it's like not enough, basically. Well, if you do the nth root here of 6, and you got to do the to infinity, that kind of stuff, this here, I believe, just goes away. Like, and I'm pretty sure at least. Well, the nth root. See, I was thinking like the square root of infinity, and that does keep going to infinity. but it's different. It's like the roots are getting smaller. This will just go to 0. Let's just say it goes to 0. So, like, what's the 1,000th root of 2? And, like, it's really tiny, you know? At least I think. Or maybe it's a 1. Let me check it with my calculator. So what I did on my paper, on my notes, I just let it go. But what if I do the, like, nth root kind of thing? So I'm going to do 2 to the 1 divided by 100 power. And yeah, so I was actually mistaken a lot about this. So it goes away, yes. I'm going to say this equals 1. Okay, I'm going to write that down in my notes so in the future I know too. So this actually just equals a 1 because I did in my calculator 2 to the 1 over 100, and that's basically the 100th root of 2, and I got 1.0069 blah blah blah. And so what's going on is that it's getting closer to 1, and so you still don't worry about it. And we're going to focus on the other side of things here in just a second. Okay, so. Glad we talked about that. What about this thing? So we got this one. This here equals 1. We're done with that. So what about this thing right here? And I'm going to say that this guy's special. And we have seen him before, but it rarely comes up. What it actually ends up being is E. This guy right here, limit goes to infinity, blah, blah, blah. It's just E. 2.70828, da-da-da. So what I got is 1E. And, well, just like I said, it's 2.71828, etc. But that's more than 1, and so thus it's going to diverge, and that's my answer. Okay. So could I have looked at this and just said, oh, well, that diverges? Honestly, no, I wouldn't have looked at it like that. I mean, if you're a professional, maybe, but I can't do it, so, well, there you go. Next one, 11,6033. So I've got summation of -1 to the n, so it's alternating. I got arctangent of n, which is kind of interesting. We'll talk about that in here in a second. And then I got n to the 5th power. I'm just going to say right immediately, this guy converges all day long. So there's a few reasons why this converges. First off, the alternating part, it helps it converge. So what I would do is find the limit of this guy over here separately, and I'm going to do that. So if you plug in an infinity for arctangent, if you remember arctangent, it actually stops at pi over 2, and so you literally just put a pi over 2 in the top. But because you got an infinity down here, infinity to the 5th power regardless, and what you got is, you know, like 1 over infinity is a 0. And what we were looking, because alternating, we did the limit, if it equals 0, that's going to converge. So that's already good enough. And I would just call it a day there. Another bigger side of things is, does it converge absolutely? If you remember back a couple sections with this alternating stuff, if it converges with the alternating, well and fine, so it converges conditionally. But I would still have to look at it without the alternating to see if it's going to converge absolutely. I do not think that they're asking that on this question. I think it's just converge, diverge, which it converges. But let's just say that the alternating was gone, and I have to decide, is it converging conditionally or converging absolutely? Well, now I have to just look at this guy now with the summation, not the limit here, just the whole summation, see what it happens. So this is equally easy because the top is pi over 2. Yay! And the bottom here is a polynomial, and that's much bigger than a constant number. And so what we got is, I don't know, 1 over like a huge number here. And so then that's 1 over infinity is a 0, converges, that kind of stuff again. Notice that I'm using this kind of comparison test thing like almost every time. I guess another way, here's a third way, I have it in my notes here, is that I could just say this is kind of equal to this guy here, and then I use the p series. And because p is greater than 1, then it converges. That 5 right there. So many different ways to do it. And that is good. Okay, hold on. Oh. No. Huh. I feel like I skipped a page here. I'm looking at my notes, and my numbers are going backwards. And I thought that I had done everything. Maybe I didn't. Oh, well. Yeah, I have... Oh, I'm seeing it now. That was the previous section. Moving on. Sorry. A little bit impromptu here. So, I've got summation of n divided by 3 to the n. And this is actually strange because they want you to approximate using the first 8 terms. All right, well, what does that mean? So basically, I'm plugging in a 1, plugging in a 2, plugging in a 3. So 1, 3 to the 1, 2, 3 to the 2, 3, 3 to the 3, yada, 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 all the way to 8, 3 to the 8. And you know what I did to get this? I actually just used a calculator, typed it all in, and I got a number. 3 decimal places, 0.749. Awesome. And then they want to know, well, what does Rn equal to? And I'm just going to give you the answer here. It's 0007. Now, how did they get that, and what is going on? There's a separate little formula for all this stuff, and we might have seen it before. I don't know. So R sub 8, which is what we're trying to find, is less than or equal to... I have A sub 9. So this is weird, okay? Hold on. That's an A, and that's a little 9. And then divided by 1 minus R sub 9. Well, the ratio is going to be, I got A sub 9 yet again, and then I've got A sub 10 over A sub 9. Yep. Whew. So this is the 8th term right here. You would have to go to the 9th and the 10th terms, plug them in, and just, well, there's your answer. So, I mean, it's not hard. It's just kind of silly, and I don't really like it anyway, so whatever. Okay, that's it. That's all I got for that section. So thank you very much, and have a great day.